Hi everyone, in this video we solve problem 3.2 from the book Applied Thermodynamics, McConkey and Eastop. Here is the statement of the problem 2 from chapter 3. A rigid vessel of volume 1 meter cube contains steam at 20 bar and 400 centigrade. The vessel is cooled until the steam is just dry saturated. Calculate the mass of steam in the vessels, the final pressures of the steam, and the heat rejected during the process. As it said, the vessel is rigid. So it means that the volume V1 must be equal to V2 and it is 1 meter. Initial pressure P1, that is 20 bar, and temperature T1, that is 400 centigrade. Condition of the steam initially is superheated. The vessel is then cooled, means to say heat rejection is taken place. The final pressure of the steam V2. Also it said the final condition of the steam is dry saturated. Now let's come toward its solution. Rigid vessel in which there is a steam. Initial condition of the steam is temperature T1, pressure P1, and the steam were superheated. Then heat rejection from the vessel is taken place, due to which its temperature and pressure drop. Similarly, the condition of the steam from superheated drop to dry saturated steam. Let me draw its PV diagram. Initially the steam is in the superheated region. This is, let's say, its pressure P1, corresponding volume is V1. Then heat rejection is taken place from the superheated region reached to the dry saturated condition. Initially the steam is in the superheated region. After then heat rejection, the steam is in the dry saturated region. And here the pressure is P2. The volume V1 final state is equal to volume V2 because the vessel is rigid. And it's obvious that the steam initials and final state volume must be the same. Now at 20 bar and 400 centigrade from the superheated steam table, this is the portion of the steam table. At this 20 bar and 400 centigrade, you can see the specific volume value is 0.1511 meter cube per kg, and the internal energy U1 value is 2946 kilojoule per kg. So let me write its value. Now to find the mass, the amount of mass present in the rigid vessels, that must be equal to total volume divided by specific volume. Total volume is 1 meter cube divided by specific volume, that is 0.1511. It will give you the mass that contained in the vessel. It is 6.62 kg. Now the final state, need to calculate the pressure P2. Also the specific volume must be equal to specific volume of V1 and it is 0.1511 meter cube per kg. The condition of the steam is in the final state is dry saturated. Now from this specific volume 0.1511 meter cube per kg and dry saturated steam conditions, you can see from the saturated water and steam table the specific volume and dry saturated condition of the steam. You can judge from the saturated water steam tables. At this specific volume, the corresponding pressure value P2 is almost, you will observe after interplotting, that is 13.01 bar. And similarly the UG value, that is equal to U2 value. Internal energy, this is to find the heat rejection that is taken place during this process. Now the total heat rejections during the process is equal to total mass present in the vessels plus change in internal energy, that is equal to U2 minus U1. Mass is 6.62. What is U2? That is 2590. U1 value is 2946. After solving this, you will get the heat rejection value, and it is minus 2356 kilojoule. This is the heat rejection that is taken place during the steam that is cooled down from superheated region to the dry saturated region.